We've got two more optimization problems to consider. In the first one, there is an island that needs a telephone wire. That island is 7 miles offshore, and the distance from the directly shoreline to the telephone company is 12 miles. It's cheaper to lay the wire along the shoreline than it is under the sea, and so we need to figure out how far do we go in the sea to minimize the cost. So if I call this distance x from here to there, then this distance over here will be 12 minus x. And by the Pythagorean theorem, this distance here must be x squared plus 49. So now I can come up with a cost function. I know that it's going to cost me $300,000 per mile along the portion under the sea. So x squared plus 49, and it's going to cost me $200,000 along the area on the shore. So there's my cost function, and I'm going to need to find the derivative of this. The derivative of this first part of the function will be 3 times 1/2 times x squared plus 49 to the negative 1/2 power. And the derivative of this second function will be negative 2. And I'd like to know when this equals 0. So if I clean this up just a little bit, I will have 3/2, or 3 over 2 times x squared plus 49 to the 1/2 power, and that whole thing should equal 2. And if I multiply both sides by 2, I can see I forgot something with the chain rule. So let me erase this because this is incorrect. I forgot the chain rule on this first part, because the derivative of this inside is 2x. So let's fix that. Messed up the chain rule. Easy to forget. Now we've got a correct derivative. And cleaning the derivative up, we'll end up with 3x over x squared plus 49 to the 1/2 must equal 2, because I want to know when the derivative equals 0. If I square both sides to undo the square root, I'll have 9x squared over x squared plus 49 should equal 4, or 9x squared equals 4x squared plus 49 times 4. 49 times 4 is 196. Or when does 5x squared equal 196? Well, x squared will be 196 over 5, which means x is about 6.261, and this will be miles. So I want to go over 6.21 miles, or a little bit past the middle, to minimize the cost of this entire situation. And the cost will end up being, when I substitute 6.261 into my cost function, it will end up being about $39.652. Remember that I had used 3 and 2 And those were hundreds of thousands of dollars. So this is how many hundreds of thousands of dollars. So if we convert it to normal ways we talk about money, this is going to be $3,965,200. Right? It's the approximate cost of this project. We have one more problem to consider. And the key to this final problem is reading it and interpreting it correctly. We're given a cost of a product in terms of the number of units made, and we want to find the production level that minimizes the average cost. Well, if our cost function is given to us, this 800 plus 0.04x plus 0.0002x squared, then the average cost will be that whole thing divided by x, because x is the number of units made. So we took the cost and divided it by x because x represented the number of units made. And so this will be the average cost of production. And if we want to minimize this, then we need to find the derivative, which will be negative 800 over x squared plus 0.00002. And I'd like to know when this derivative equals 0. So, going through and solving for x, we will find that x is about 40 million. So if this company makes 40 million units, then we'll minimize the average cost per unit. That seems way too small. And you know what the problem is? They didn't take the square root of this. They're way too big. So if we take the square root of this, then we'll end up with a real answer of about 6,324. Since we're rounding and you can't have part of a television set, 6,325 TVs.